Welcome to my channel. In this video, we want to look at concept of motion. Concept of motion. So what we are looking at, learning outcome. Learning outcome. At the end of this video, you will learn the following. You will know what motion is all about, causes of motion, types of motion, terms commonly used in motion. You will learn displacement time graph, velocity time graph, equations of motion, motion under gravity, and relative motion. This is what we shall be looking at in this class. Okay, let's look at motion. What is it all about? What is motion? If you have an object at point A and the object change position to another point B, we say the object has undergone motion. So what is motion? Change in position of an object or a body with time. Change in position of an object or a body with time. Okay, let's look at causes of motion. Causes of motion. Motion is caused as a result of force. So the major cause of motion is force. And we have two types of force. We have the contact force, and the field force. We shall look at each of them. What is force? First of all, force is a pull or a push. Force is a pull or a push. For instance, this is a duster. I can apply a force and I'll be able to pull it. So force is a pull or a push. And like I said, we have two types of force, a contact force and field force. So a contact force is the force applied directly to an object. Like I just demonstrated, I can apply a force. The force will make contact with the object, and through that, I can change its position. So a force that makes direct contact with the body or the object, we call it contact force. Okay, let's go to the second one, field force. What is a field force? It's a force experienced by an object or a body within a field. And by this, we have different types of field. We have electric field, we have gravitational field, we have magnetic field. So these are all examples of field. For instance, if you bring an object within a magnetic field, bring a conductor within the magnetic field, the object will experience an electric force. So if you have positive, negative charges creating an electric field, if you bring a conductor within the field, the conductor will experience electric force. Are we together? So the force experience is not that the conductor will make any direct contact. The moment it's within the field, it will experience electric force. And if it is in the gravitational field, like the Earth, an object within the Earth's gravitational field will experience gravitational force, except if it escapes from the influence of the gravitational force through what we call escape velocity. We shall be looking at that in the course of our class. So an object within the gravitational field will experience gravitational force. And if it is the magnetic field, an object within the magnetic field will equally experience magnetic force. And the type of force being experienced it is called field force. I hope we understand the difference between contact force and field force. Okay, let's make progress. Let's look at types of motion. We have different types of motion. Let's look at them. Types of motion. The first type of motion is translational or rectilinear motion. Translational or rectilinear motion. It's a motion on a straight line. So a motion on a straight line is called translational or rectilinear motion. From the name, rectilinear, linear means straight. So a motion of object on a straight line from point A to point B, we say it is what? A translational or rectilinear motion. We have the second type of motion, oscillatory motion. Oscillatory motion is another type of motion. It is a to or fro movement about a fixed point. For instance, a pendulum bulb, you hang it on a string, and the moment you display it, you discover it will move to and fro. So it undergo the type of motion called oscillatory motion. Then this other type of motion that we have, rotational motion. Rotational motion is another type of motion. And what is it all about? It's a movement of an object in a circular path about a fixed axis. Example, the fan, as the fan rotates, it moves about a fixed axis. Then we have another one, random motion. Random motion. It's another type of motion. And what is it all about? Random motion, an object moves in a non-linear manner and change direction continuously. Example, the movement of smoke. You see, the movement is not linear, it moves randomly. See it going like that. So, a motion of this nature is called random motion. So, these are some of the types of motion. Okay, let's make progress. In this class, our focus will be on translational or rectilinear motion. And like I said earlier, it is motion on the straight line. Okay, let's look at the terms that we normally use under motion. Terms that we use under motion, we shall look at each of them so that as we make progress in this class, you will really understand. So let's look at terms. Terms commonly used in motion. There are various terms, and the earlier we are familiar with it, the better. The first one is distance. Distance represent with letter S or letter D. So distance is the first term we are looking at. And what is distance? It is the actual length between 2 points in a specified path. Actual length between 2 points, point A, point B, the actual length between it, we call it distance, and the unit is in meter. Okay, the second one we want to look at is displacement. Displacement represent with letter D. And what is displacement? Distance traveled in a specified direction. Distance traveled in a specified direction. And the unit is meter. Okay, the third one, speed. What is speed? Speed is the rate of change of distance over time. The rate of change of distance over time. And the unit is meter per second. Okay, the other one, velocity, is another term we commonly use. And what is velocity? It's the rate of change of displacement the rate of change of displacement over time. The unit is meter per seconds. Okay, we have uniform velocity. Uniform velocity. What is it all about? Uniform velocity. If the rate of change of displacement with time is constant, we say that the velocity is uniform. So uniform velocity is the velocity in which the rate of change of displacement with time is constant. Okay, then we have this number 5, number 6, instantaneous velocity. Instantaneous velocity. What is it all about? Instantaneous velocity is the rate of change of displacement with time during a very short interval of time around a specified instance. So we have it that instantaneous velocity v is limit as change in time approaches 0, change in distance over change in time. So instantaneous velocity is the velocity obtained in a short interval of time as the time approaches 0. Okay, then we have average velocity. Average velocity, what is it all about? Average velocity is equal to total displacement over total time taken. Total time taken. So average velocity represented with this symbol is total displacement over total time taken. Okay, the next term here is acceleration. Acceleration represent with letter A. Acceleration is change in the rate of change of velocity with time. The rate of change of velocity with time, final velocity minus initial velocity, final time minus initial time. So then we also have uniform acceleration. Uniform acceleration. What is uniform acceleration? If the rate of change of velocity with time is constant, then what we have is uniform acceleration. The last word here or term is deceleration. Deceleration or retardation. Deceleration or retardation is another term that we commonly use. And what is it? It's the rate of decrease of velocity with time. The rate of decrease of velocity with time. And it is normally negative. Deceleration is normally negative. So these are the terms that we use under motion. We shall be looking at it: distance, displacement, speed, velocity, uniform velocity, instantaneous velocity, average velocity, acceleration, uniform acceleration, and deceleration or retardation. So these are the terms we shall be using then, and it is good you are familiar with all of them, know the definition, know the equation that we use, so that as we make progress, when we go into aspect of calculation, it will really follow. Are you together? Okay, so let's make progress. Let's look at one or two examples of how we can use this term and this equation. Example. So, example 1. Example, you can write, or let me read out the equation, then we look at it together. If a runner moving in a straight line takes 10 seconds to run 200 meters, find the average velocity in this direction. So to solve a equation like this, the first thing you do, you look at the information given, what we call given data. So we are looking at the solution to this problem, solution. So given data. And how do you get the data? As you read through the equation says if a runner moving in a straight line takes 10 seconds, so we have the time, 10 seconds, to run 200 meters. 200 meters, that is distance, 200 meters. Find the average velocity in this direction. The velocity we don't know. So, but we know the formula. So using the equation, velocity is equal to what? Distance over time. Let's substitute and see. The distance is 200. The time is 10. So 0 cancel 0 here. We have 20 meter per second. So this is our answer. So the average velocity of the runner who moves in a straight line in 10 seconds covering 200 meters, the average velocity is 20 minutes per second. Okay, let's look at other example. Let's look at other ones. Okay, example 2. Example 2. A car accelerates from 15 meter per second to 35 meter per second in 15 seconds. What is the average acceleration? Okay, solution. What are the given parameter or given data? And like I told us earlier, we get it from the question. As you read through, you bring it down step by step. A car accelerates from 15 minutes per second. That would be initial velocity, 15 minutes per second, to 35 meter per second, in 5 seconds. So find the acceleration. We don't know. So using the formula acceleration, we say is what? The rate of change of velocity with time. So this is the formula we are using. So the next thing we substitute 35 minus 15 over 5. 35 minus 15, we have 20. 20 divided by 5. So our acceleration is 4 meters per second square. Is it difficult? No. So this is the approach that we use. It's very simple. All you need to do, bring out the given parameter, know the formula, then the rest is mathematics. You substitute and you get your answer. Okay, let's make progress. We want to look at method of solving problems. Method of solving problems in motion. Method of solving problems in motion. We have two methods that we use to solve a problem under motion. One of it is graphic method or graphical method. The second one is equation, through the use of equations of motion. So these are the two ways that we can solve problems under motion. Okay, let's look at each of them and how we apply them. So the first one we want to look at is displacement time graph. Displacement time graph. And we use displacement time graph to find velocity. So the graph of displacement, graph of displacement in meter against time in seconds give us what we call displacement time graph. So if you plot the graph of displacement against time, let's say, let me label it very well so that we understand. You have an object being displaced at, let's say, one point, and at another point, call it D2, and at a time T1, at another time T2. So for us to find the velocity, say velocity is what? Change in displacement over change in time. So it will be the slope of this plot. So it will be D2 minus D1 over T2 minus T1. So if you know the initial time, know the final time, know the initial displacement and the final displacement, you will be using this graph to compute the velocity. So I told us we have two methods. This is the graphical method. And this graph is called displacement time graph. Displacement time graph. So we use this to find velocity. So let's look at the second one. The second one is acceleration. Acceleration. And the graph that we use, we call it velocity time graph. So you have graph of velocity in meter per second against time in seconds. So if you have an object, just listen and watch. Have an object that starts from rest. The object move starting from rest, having initial velocity 0. It moves, accelerate to a point, then continue and reaching at another point, move to a point, let's call it T1, continue, accelerate to another point, call it T2, then it now decelerate to another point, T3. So this first part here, this acceleration, then this one, as you can see, this is what we call uniform acceleration, when the rate of change of velocity with time is constant. So this portion is called uniform acceleration. Then we talked about deceleration. What is it all about? When the rate of change of, when the rate of decrease of velocity with time is called deceleration, or what? Retardation, deceleration. So from this graph, we have gotten information about the acceleration, about uniform acceleration, and about deceleration. So we can use this approach. Then, if you look at this, this is a shape of a trapezium. So the total distance covered, if we label this, this is 0, this is A, this is point B, and this is C. Then let's say this point is D and this point is E. So the total distance covered, total distance is equal to area of a trapezium. Area of a trapezium. And what is the formula for area of a trapezium? Let me bring it here so that we can see it very well. Area of a trapezium, is equal to half AB plus OC into AE. So let's look at it. We say the total distance covered is equal to the area of the trapezium. This is the formula we use. Half AB. See the AB. Distance from here to this point is the AB. Then plus OC. OC, this length, times AE. This is the height, AE. So we can use this formula to calculate the total area covered from in this diagram. So like I told us, two methods, graphical method and equations of motion. So this is all about the graphical method. Okay, let's look at the second method, equations of motion. Equations of motion. That is the next thing we are looking at. We can use equation to calculate, to solve problem under motion. So let's look at the equations of motion. After we looked at equations of motion, then we solve one or two examples. Okay, equations of motion. There are four equations of motion. The first one, V equal to U plus AT. Let's call this equation 1. S equal to UT plus half AT square. This equation 2. V square equal to U square plus 2AS. This equation 3. And the fourth one, S is equal to V plus U over 2 into T, equation 4. So these are the four equations of motion. We will not go into the derivation of this equation, but I believe you are familiar with this before now. So we will be using the graphical method and these equations of motion to solve example so that you better understand what we are looking at. Okay, let's look at example. I will read out the equation, then we'll look at it together. A train starts from rest and accelerates uniformly at the rate of 2 meters per second square until it attains a maximum velocity in 15 seconds. It then travels for 30 seconds at that velocity and is brought to rest with uniform retardation after 10 seconds. Draw a graph of the motion. Use the graph to determine the maximum velocity reached, the retardation, the total distance covered, and the average velocity of the journey. So we are going to use graphical method to solve this problem. Okay, let's look at it. The first question says, draw a graph of the motion. So to draw the graph, we'll be following the equation like I told us, getting information, and it's those information that we'll use. So a train starts from rest. So by that, you have your velocity in meter per second, then time in seconds. So a train starts from rest, meaning the initial velocity is 0. Start from rest, move gradually, and accelerate uniformly at the rate of 2 meters per second. So we know acceleration to be 2 meters per second square. We shall be using that until it attains a maximum velocity in 15 seconds. So it moves attaining maximum velocity in 15 seconds. It then travels for 30 seconds at that velocity. So this is the maximum velocity. It continues for another 30 seconds. So 30 plus 15 is 45. I hope we are following. And is brought to rest with uniform retardation. Told us about retardation, brought to rest, uniform retardation after 10 seconds. So it's brought to rest. So 10 plus 45 will be 55. So this is the total time taken for this journey. So this is a velocity time graph that I showed us earlier. Okay, so the first question says we should draw. We have drawn our velocity time graph. The second question says, use the graph to determine maximum velocity. Maximum velocity. We don't know the maximum velocity, but we know the acceleration and we know the time. And remember, so we are the first question here, maximum velocity. So we have to find the maximum velocity. So we are going to use this expression, acceleration is equal to what? Change in velocity over change in time. Okay, let me take it up here so that we'll be able to see it very well. The first question says we should find the maximum velocity. So we are using this formula. Say acceleration is equal to final velocity, initial velocity, change in time, initial and the other one. So when we substitute this, the initial velocity is 0. We know the acceleration to be 2. The final velocity we don't know. Initial velocity is 0 because it starts from rest. Then initial time is also 0. Move to the other time, 15. So we have 2v over 15. So if you cross multiply, velocity will be what? 2 times 15, which will be 30 meter per second. So the maximum velocity reached here is 30 meter per second. Is that taken? So we have answered the first part of the question. Okay, the second one says total distance travel. Total distance. That is the next one. Total distance. And I earlier told us that the total distance traveled is equal to area of a trapezium. So let's label it this O, this A, B, C, D, and E. So this is the labeling. And what is the formula? The formula for area of a trapezium is half into AB plus OC into AE. So let's substitute half into AB. AB is what? 30. 30 plus OC. OC is what? 55. 55 into AE. AE is what? Okay. AB is 30. Yes, we are right. Then AE is also 30. Okay, let's simplify and see. Half 30 plus 55 is 85 times 30. So 2 we go, we'll be left with 85 times 15. And if you simplify, you will have 1275 meter. So this is the total distance traveled by this train moving from rest down to maximum velocity, maintaining uniform acceleration and retard at time 55 minutes. So this is the total distance traveled. So the last question here says we should find the average velocity. Average velocity is the next thing we want to find. Average velocity is equal to total distance traveled, total distance over total time taken. Total time taken. So we have seen the total distance. This is the total distance. And this is the total time taken for the journey. So let's substitute 1275 divided by 55. So it will be equal to 23.18 meter per second. I believe this is what you have in your calculator. So this is the average velocity as the car moves from rest down to covering a distance of 1,275 meters. So this is the graphical method. This is how we use the graphical method to solve problems in motion. I hope it's not difficult. All you need to know, understand the graph as I explained earlier, then the total distance will be equal to the area of a trapezium. So it's very simple. Okay, let's use the equations of motion. Let's solve example using equations of motion. This example is under graphical method. So we want to look at example using equations of motion. So example, this should be example what? I'm not even numbering it. Okay, let's go. Example, an aeroplane lands on a runway with a velocity of 50 meters per second and decelerate at 10 meters per second square to a velocity of 20 meters per second. Calculate the distance traveled on the wrong way. So this is the question before us. Solution, we have to find the solution. So what we do here, the given data, you remember, I told us this is the starting point, and for us to get it, we read through the equation. An aeroplane lands on the runway with a velocity of 50 meters per second. So this will be the initial velocity. Are we together? And decelerate at 10 meters per second square. So deceleration 10 meters per second square to a velocity of 20 meters per second. So this is the final velocity. Calculate the distance traveled, the distance we don't know. So this is the given parameter. Let's substitute. First of all, which equation are we using based on this parameter? Okay, tell us the equation we shall be using. Let me see whether you are actually following. Among the four equations of motion, which one are we using? We have the initial velocity, we have acceleration, we have a final velocity, then we have to find the distance. You can use S or D or S. They are all the same in place of distance. Okay, looking at the four equations of motion, which one do you think is suitable? Okay, gaze, let's see, look at it, look at it. Yes, this is the equation we shall be using. We know the final velocity, we know the initial velocity, we have the acceleration, we have to find the distance. Okay, let's substitute and see. 20 square is equal to 50 square plus 2 into minus 10 times s. Do we know why this is minus? I told us earlier, this is the acceleration. Anytime we say deceleration is negative, the rate of decrease of velocity with time. So that is why we have the minus there. So if we simplify, we'll have 50 square minus 20s, this 20 square. So if you simplify this, 400 2500 minus 20s. So s will be 2500 minus 400 over 20. So if you simplify this, you have 2100 over 20. So the distance covered will be 105 meters. Is it difficult? No, it's not difficult. Okay, so this is how we go about it, bringing out the parameters, the given data. From there, choosing the rightful equation that has the parameter that we are given and knowing the one we are looking for. Then the rest is mathematics. Is this not mathematics? For some of you that say you don't like mathematics, there is no way you can do physics course without mathematics. So the rest here is mathematics. Okay, let's look at another example. Another example. A car moving with a velocity of 15 meters per second accelerates uniformly at the rate of 2 meters per second square to reach a velocity of 20 meters per second. Find the time taken, the distance traveled in this time. Okay, as usual, Let's look at the given information solution. So given data, we are given the initial velocity to be what? 15 meters per second. Acceleration is 2 meters per second square. Then final velocity is 20 meters per second. We have to find the time. We don't know. We have to also find the distance, which we don't have idea as well. Okay, so which formula do we use? Which formula? Right, suggest the formula. Let's see, look at the formula. Which one do we use? Okay, this is the rightful formula. U plus V equal to U plus AT. This will help us to get the time. We know the final velocity, we know the initial velocity, we know the acceleration. So we are looking for the time. So let's substitute and see. 20 equal to 15 plus 2t. So from here, if we make this the subject formula, we have 20 minus 15 over 2. And that will give us what? 2.5 seconds. So this is the time taking. So the next one, we have known the time taking. The next one is the distance. So which formula do we use? Write the formula, let's see. Have you written them? Right, let's see. Okay, ut plus half at squared. Is this what you have written down? So this is the formula we are using. Okay, let's substitute and see. The initial velocity 15 times 2.5 plus half times 2 times 2.5 square. So from here, if we simplify, 37.5 plus 6.25. If you simplify, what do you have? Okay, this is what I have. So the total distance traveled in this time is what? 43.75. Is it difficult? No. Okay, let's have one more example so that I believe with that you will actually understand what we are discussing. So let's have another example. You can write. Let me read it out. A boy starting from rest travels for 30 seconds. Determine the final velocity attained after covering a distance of 40 meters. So you try this. Let's see. Solution. Try it. Given data. What are the given data? Let me see your given data. The given data. Say a boy starting from rest. With that, the initial velocity is 0. Travel for 30 seconds. That is what? The time, 30 seconds. Determine the final velocity attained. Final velocity we don't know. After covering a distance of what? 40 meters. So which formula do we use? Using the expression, which formula, which expression? Write it down. Let me see. Okay, this is the expression we'll be using. S equal to ut plus half at squared. So the distance is 40. The initial velocity is 0. 0 times the time will be 0 plus half acceleration 30 square. So let's simplify and see. From here, if you cross multiply, you have 80 equal to what? 30 square is 90. It's 900A. So from here, A will be equal to 80 over 900. So this will give us 8/90 meter per second square. So this is the acceleration. We are looking for velocity and not acceleration. So do we know the formula relating acceleration and velocity? Yes. So we use V equal to U plus AT. We are looking for this. The initial is 0 plus 8/9, which is the acceleration. Are we together? Times the time, 30 seconds. So from here, if you simplify, you have 2.9 meter per second as our velocity. So this is the final velocity attained after covering a distance of 40 meters. Is it difficult? Okay, so we have solved so many examples using the graphical method and the equations of motion. I believe with this, you understand, and any other question you lay your hands on, you will be able to solve. And like I said, the procedure, you read through the question, the given data, you bring them out. From there, you think of what you are looking for and the formula that you can use. So that is the approach to solve it. Okay, the next thing we want to look at is motion under gravity. Motion under gravity. Let's look at it. Motion under gravity. Since we have been talking about linear motion, a motion too can be under gravity. So motion under gravity is defined as the movement against the influence of the Earth's gravitational force. So when force is applied to an object, it can either move horizontally or vertically. So if you have an object like this, apply a force to it, can make it move horizontally, can make it move vertically. And when it's moving vertically, it's against the influence of gravitational force. So the equations of motion that we have before now, you remember U equal to AT, V square equal to U square plus 2AS, and S equal to UT plus half AT square. So this is the equation we earlier have under linear motion. And under linear motion, we talk of acceleration. Then under motion under gravity, we talked about acceleration due to gravity. So in that case, the A here changed to G. So we'll be having this, and also this. Are we together? Then one needs to remember this. The acceleration due to gravity, it can either be positive or negative, depending on the gravitational force. If an object is being thrown up, you know it's against the influence of gravitational force. In that case, the G here is negative. Are we together? And for an object that is falling, it's not against the influence of gravitational force. So G is positive at that point. So this equation varies based on how the gravitational force is affecting it. It can either be positive or negative. Okay, let's solve an example to actually see what we are talking about. Example. Okay, let me read out the question. A bricklayer plastering a house falls from an uncompleted building of height 50 meters. Calculate the time it takes to fall and the velocity with which it hits the ground. So let's look at it. Solution. Given data, you remember? Okay, so we have the initial velocity. The bricklayer was at rest. before the fall. Then the height with which he falls from, 50 meter. Then the acceleration due to gravity is 10 meter per second square. And let me ask you, this acceleration, the bricklayer that is falling, is he working against acceleration or is just under the influence? Since it's falling, it is not against acceleration. So the G, the value here is positive. You remember, I told us it can either be positive or negative, depending on what we are looking at. Okay, so we are to find the time taken. We don't know the time. And also the velocity with which he fell from that height. So we will be using this formula, S equal to UT plus half gt squared. Okay, let's substitute and see. 50, the initial velocity is 0. So here will be 0 plus half 10 into t. So this will give us 100 equal to 10t. From here, the time taken will be 100 over 10, which will be 10 seconds. Is it difficult? Okay, sorry, the t here is square. Sorry for that. So the t here is square. So we have 10. So we are looking for t and not t square. So if you simplify this, you have 3.16 seconds. So this is the time taken. So this is how we go about this question. So we are to find the time, also the velocity. How do we find the velocity? V is equal to what? U plus gt. So the velocity now, the initial is 0 plus the acceleration 10 times 3.16. So this will give us 31.6 meter per second. This is the velocity with which the man hit the ground. Okay, thank you very much. Let's make progress. The next thing we want to look at is Newton's law of motion. Newton's law of motion is the next thing we want to look at. There are 3 laws: the first law, the second law, and the third law. Let's look at each of them. Newton's laws of motion. Newton's laws of motion. Okay, let's look at the first one. First law. Okay, Newton's first law of motion states that every object in the universe will continue to be in its state of rest or uniform motion in a straight line unless it is acted upon by an external force. By that, it means an object at rest, for instance, you put this duster here, supposed to remain here forever. Or an object in motion will continue unless force is being applied. So that is the statement of Newton's first law of motion. And Newton's first law of motion is also called the law of inertia. The law of inertia. And the inertia of a body is the reluctance of the body to remain at rest or its reluctance to be brought to rest if in motion in a straight line. An object at rest will continue, that reluctance to continue to be at rest, or if it is moving, that reluctance to continue to move. We call it inertia. Okay, let's look at Newton's second law of motion. Newton's second law of motion states that the rate of change of a body is proportional to the external force and takes place in the direction of the force. So here we say momentum from the statement, momentum P is equal to mass times velocity mv. Then say the rate of change of momentum is equal to mv minus mu over time. And according to Newton's law, we say that external force F is proportional to mv minus mu over t. So if you remove the constant of proportionality, introduce equality sign, you have km, if you factor this, v minus u over t. F will be equal to ma. Note that a is v over u acceleration, and if k is equal to 1, we will have this. So this is the mathematical statement of Newton's second law of motion, and we can state it using this mathematical statement that Newton's second law of motion states that the acceleration of an object is directly proportional to the net force acting on it, but inversely proportional to its mass. So we are saying that F is equal to F over m. So we can use this to state Newton's second law of motion. Then the third law, let's look at it. Newton's third law of motion. It states that to every action, there is always an equal and opposite reaction. To every action, there is always an equal and opposite reaction. Let me give us an instance. For instance, if you knock your head, knock it small, you feel a small force. If you knock it harder, you feel much pain on your hand. Why? The action, knocking is an action. Then as you knock the head will equally react. That is what reaction. So according to Newton's third law of motion, that to every action, there is always equal and opposite reaction. So thank you very much for watching. Please like, share, and subscribe to my channel for more videos. Now, next video, we shall be looking at gravitation. So thank you very much.